Hello everyone. In this video, we will be discussing the design procedure for Spur gear. Because for solving the problems, the design procedure is mandatory, and if we follow this design procedure, where we supposed to use, like the formulas from the data handbook, or like for standard values, which table should be followed, and where we need not to use the formulas from the data handbook, which formulas we supposed to remember, and the basic concept of deciding pinion and gear. So all those things will be known only if you properly thorough with the design procedure. So the first step in the design procedure is identification of the weaker member. As we know that we will be having two like gears, so we will be identifying the weaker member among that one, and we will be naming that as a gear and pinion. So for that we will be finding out the product of allowable stress and from the Lewis form factor of both the gear and pinion. So whichever has the lowest value, that will be considered as the weaker member. In if both pinion and gear is made of same material, then pinion will be considered as the weaker member, as the diameter of the pinion will be usually less than the gear. So once again I'll repeat, if with the product of allowable stress and Lewis form factor of both gear and pinion, whichever have the lowest value, that will be considered as the weaker member. And second option is, if both gear and pinion is made of the same material, then pinion will be considered as a weaker member, as the diameter of the pinion will be less than the gear. You can able to see here allowable stress and the Lewis form factor. So that is sigma 1 into y1 and sigma 2 into y2 for the pinion and gear. So how we can select the Lewis form factor means we can able to select from the data handbook 23rd chapter. The equations are from 23.115 to 23.117. All these for the different angles it is there. So for 14.5-degree involute, the Lewis form factor y will be equal to pi into 0.124 minus 0.684 divided by z. Similarly, for a 20-degree full depth teeth, the y is equal to pi into 0.154 minus 0.912 by z. And for 20 degree stub teeth, y is equal to pi into 0.175 minus 0.950 divided by z. And if allowable stress is not given, then select the allowable stress value from the table 23.18a for the given material. Definitely the material name would be mentioned in the question. So accordingly we can able to select the allowable stress, because based on this Lewis form factor and the allowable stress only we can able to find it out which is the weaker one. And next one, after identifying the weaker one, whether the gear or pinion, we need to focus our design for the weaker member only, because the other one is by default it is a stronger one. So our design should be focused only on the weaker member. So first, when in the design of the weaker member, we need to find out the tangential tooth load from the design data handbook chapter 23 and the equation number 23.87b. So we will be finding out the tangential tooth load, and which is denoted as Ft. The formula is 9550 into capital N, that is power, and C suffix s, which is nothing but service factor, and divided by small n is nothing but the speed, and a small r is nothing but the radius. So here all the data will be available, or else will be given in the question. So n values, capital N, small n value, and r value. But CS value is the service factor. We supposed to take it from the table 23.13. So while solving any problem, I will tell you on what basis we have to select the service factor value. And in the same step we will be finding out even the tangential tooth load from Levy's equation, that is equation number 23.93 from the design data handbook, and the formula is Ft is equal to sigma 0 into by p kv. So here the b is nothing but the width, face width, so that is 9.5 meter to 12.5 meter from the equation 23.132. So we need not to worry about what is this face width value. And y we know that which is this is allowable stress, b is like face width, y is nothing but the Lewis form factor for the weaker member, p is nothing but the pitch, and the formula to find the pitch is pi into module m, and kv is nothing but the velocity factor. And to find out the velocity factor, we need to calculate the mean velocity, that is the formula pi dn divided by 60,000. And we can able to see, like, based on the different velocity, we have a different velocity factor formula, starting from 23.134a or 23.135a, 23.136a, 23.137a. So if the velocity value If it is less than or equal to 7.5 meter, then the formula would be 3 divided by 3 plus Vm. And if the velocity value is up to 7.5, up to 12.5 meter means the formula will be 4.5 divided by 4.5 plus Vm, and it is up to 20 meter per second means 6.1 divided by 6.1 plus Vm, and if it is more than 20 means that is 21, 22, 23 means the formula will be for the velocity factor it is 5.6 divided by 5.6 plus square root of Vm. And from the above two equations of the tangential tooth load, by trial and error method we can find out the module M, and after finding out the module value we need to select the standard module from the table 23.3. Then moving to the third step, that is checking for the stresses. So we will be calculate the induced stress by the equation, that is the induced stress is equal to allowable stress into velocity factor, which is the induced, which is equal to Ft by B into Y into P. So we will be calculating the allowable stress by the equation, that is allowable stress is equal to the sigma naught into Kb into the allowable. So we will be checking out whether it is coming in the less than the given calculated value. Then based on that, if it is coming the induced value is less than the allowable value means, then we can say that the design is satisfactory. Then step 4, which is nothing but calculating the dimensions, because in the previous step where the tangential load, the stresses, based on the velocity, all those things we would have found out. So now probably there would have there is no scope of making errors in the design, so we can directly suggest the dimensions of the gears. So we will be calculating all the important geometric parameters of tooth profile from the equations given in the table 23.1 based on the pressure angle. So what and all we will be finding out? We will be finding out addendum, that is denoted as HA. We will be finding out dedendum, that is denoted as HD. Tooth thickness S, total depth H, clearance C, and the outside diameter of the gear and pinion will be finding out like D1 and D2, tangential tooth load, that is Ft, center distance, face width, and root diameter of the gear and pinion. And fifth step is nothing but checking. So after finding out all these value, we need to check it out whether our dimensions whatever we found it is correct or not. So how to check means we will be checking for the dynamic load according to the Buckingham equation. The dynamic load formula is Fd is equal to Ft plus 2 LVM into Ft plus BC divided by 2 LVM plus square root of Ft plus BC, which is available in the design data handbook, equation number 23.155, where C is nothing but the load factor and which can be obtained from the table 23.32 and the figure which is available in the data handbook 23.35a. If the class of the gear is known, then the error of whether it can be obtained from figure 23.34a. And in the same step checking where along with the dynamic load like bucking the equation, we will be checking even endurance strength of the gear tooth. So endurance strength is denoted as F suffix minus 1. So the formula for that one is sigma suffix minus 1 BYM. So the equation is 23.158, where Y is nothing but the Lewis form factor, that is pi into Y, and the endurance limit we can take it on from the table 23.33, and the endurance stress formula is nothing but 0.5 times of ultimate stress value. For the safer design, Fd must be less than the allowable endurance strength. And similarly, in the same step, we will be checking out the wear load again by using the Buckingham theorem wear load, that is 23.160. The formula is Fw equal to D1 into B into Q into K. So where Q is nothing but a ratio factor, which is having the formula 2Z1 divided by Z1 plus Z2. We know what is Z1. Z1 is number of teeth on the gear, pinion and gear, where K is nothing but the load stress factor, which can be calculated by equating wear and dynamic load equations. So for safer designs, Fw value must be greater than Fd. That is the important thing. Usually it should be lesser, the induced value should be lesser than the allowable value, but only for the wear load we need to check it out, it should be greater than the Fd value. If not, then make one or more following changes, that is decrease the module M, or increase the face width B, or increase the surface hardness, or calculate Ft by decreasing error. So in the next video we will discuss the problem on the Spur gear. Thank you.